Hi everyone, and welcome to this webinar today. I do want to note before I get in that I will be referring to the system as the NextSeq 2000 throughout the presentation for simplicity. Let's dive in. Our agenda today is we're going to take some time to talk about the system overview. We'll discuss the reagents, the workflow, use of custom libraries on the instrument, maintenance, sequencing data, tips and tricks, and resources. Starting off with the system overview. The NextSeq 2000 fits nicely into our current platform, our current instrument portfolio. It is good for high throughput personal scale as well as low throughput production scale. There are two different flow cell offerings on the NextSeq 2000. The P2 flow cell offering 400 million reads and the P3 flow cell offering 1.1 billion reads. There are three key technologies that help enable the high throughput and reduced sequencing costs on the NextSeq 2000 when compared to the NextSeq 550. The NextSeq 2000 utilizes a patterned flow cell system, as well as a new blue-green 2-channel SBS chemistry. These two combined with the super resolution optics help enable that higher throughput at reduced cost. There's the major increase in density also translates to less waste, less complexity, and more value per run when compared to the NextSeq 550. On the left-hand side of the screen, you can see the comparison of the NextSeq 550 flow cell to the NextSeq 2000 P3. This tiny flow cell allows for 2.5 times higher output when compared to the 550. It also allows for 2 times lower dollar per gigabase. And we also have a 4 times smaller reagent size footprint compared to the NextSeq 550. The NextSeq 2000 boasts approximately 160 square inches of reagent footprint when compared to the NextSeq 550's 650 cubic inches. Some of the specifications for the NextSeq 2000, I have highlighted here all of our different current run options available. I'll discuss the P3 2x150. For the 2x150 using P3 reagents, the specification is 330 gigabases with a Q30 of greater than 75% and a runtime of approximately 48 hours with 1.1 billion reads passing filter. Comparing the specifications for a 2x150 run on the NextSeq 550 versus the NextSeq 2000. For the P2, it is comparable to the NextSeq 550 high output flow cell. For 29-hour runtime, 120 gigabases output, 400 million reads, and a quality specification of 75%. However, we do also have the P3 flow cell, which allows for a much higher yield with 330 gigabases and 1.1 billion reads passing filter. The NextSeq 2000 offers a streamlined workflow, allowing users to plan their run within BaseSpace Sequencing Hub with flexible modes of operation, sequence on the instrument using integrated DRAGEN for fast analysis in parallel, and allowing analysis using an automated turnkey solution either on board or in the cloud. NextSeq 2000 integrates the DRAGEN platform on board. It allows for fast, accurate, industry standard pipelines that are appropriate for both novice and expert users. Some of the pipelines that are currently available on board are Enrichment, RNA, germline, single-cell RNA, as well as generate FASTQ via BCL Convert. There are additional pipelines available within BaseSpace Sequencing Hub. Something different about the NextSeq 2000 compared to our other instruments is that it runs on Linux. This helps to offer better security than Windows, as Linux has a less inherent vulnerability to viruses and malware when compared to Windows. There are less frequent OS updates, and it has a higher reliable stability. The NextSeq 2000 utilizes TeamViewer. For those of you not familiar with working with Illumina tech support, there may be instances in which we ask to connect into your instrument either for help in setting up runs or remote troubleshooting. TeamViewer allows us to do this. I have linked on the top right to our Share page with more information for TeamViewer as well as instructions for downloading. Once TeamViewer Quick Support application is downloaded, all you have to do is launch the Quick Support application and then provide tech support the ID and password. The NextSeq 2000 also has integration with Illumina Proactive. Illumina Proactive allows tech support access to critical files to aid in quicker remote troubleshooting. It allows tech support to review SAV data without having to remote into the instrument or collecting data. It also allows customization of My Illumina customer dashboards to help maximize visibility into instrument performance. I have linked here some various resources for Illumina Proactive. Okay, we've finished up with the overview and moving on to the reagents. Currently, we have V3 P2 kits offered in 100, 200, and 300 cycles. Each of these kits has an additional 38 cycles to allow for indexing. We also have V3 P3 kits, which include 50 cycles, 100, 200, and 300 cycles. The 50, the 100, and the 200 all include the extra 38 cycles to allow for indexing. The 300 cycle P3 kit only includes an additional 27 cycles for indexing. I have listed the part numbers on this slide for your reference. Something that you might not be familiar with on our other platforms that is new with the NextSeq 2000 is it has a Fluidics system integrated within the cartridge. This is much like the iSeq 100 sequencing platform, and it allows for the Fluidics to be single use. The Fluidics system is disposed of at the end of each run, and it helps to prevent instrument-related Fluidics issues. Moving on to the workflow. We're going to start with discussing how to thaw the cartridge. It is really important on the NextSeq 2000 that we ensure that we are planning ahead when we are thawing and planning our experiments. The thaw times for the NextSeq 2000 cartridge are much longer than we may be used to on some of the other Illumina platforms. We also want to ensure that we are thawing the cartridge in an unopened foil bag that it comes in. Our first option for thawing is to thaw in a temperature-controlled water bath. This allows us to start thawing the same day as the sequencing run. This can be done by thawing at 25 C for 6 hours with a maximum of 8 hours. Our next option is to thaw in the refrigerator. This allows us to start thawing 1 day before the run starts. When using the refrigerator thaw option, it does require to thaw at room temperature for 6 hours with air on both the sides and top. After 6 hours, the cartridge is then moved to 2 to 8 C for 12 hours, or a maximum of 72. If using this option, we want to make sure that we remove the cartridge and set it at room temperature for 15 minutes up to 2 hours before sequencing. Our last option, which also allows us to start thawing 1 day before the run, is to thaw at room temperature for 9 hours and a maximum of 16. We've got our cartridge thawing. Now let's get ready to set up our sequencing run. We have a couple different options for run setup. We can use local only, which is V2 sample sheet driven for the run configuration and utilizes the onboard DRAGEN analysis system. There is the hybrid option, which utilizes BaseSpace for run setup and will then utilize onboard DRAGEN analysis. We also have cloud only, which uses run setup within BaseSpace and then utilizes DRAGEN analysis in BaseSpace. If using cloud run setup mode, it's not going to be using the run setups that we may be used to. We won't be using PrepTab, and we won't be using local run manager. There is a newer option under runs when choosing new run for run setup using the NextSeq 1000-2000. And this is what the run setup looks like. There's a section for you to include your run name, choose your analysis parameters, choose your library prep kit, and enter your sequencing run parameters. There's also a section in which we can enter our sample information. This can be done by manually entering each sample or by importing the sample information. For local-only mode options, this requires a sample sheet. I wanted to outline some of the differences between V1 and V2 sample sheets. As the instrument requires a V2 sample sheet, it's important to know that we should not be using Illumina Experiment Manager, or IEM, to generate our sample sheets for local-only options on the NextSeq 2000. The sample sheets are formatted fairly differently, so please ensure that we use the V2 sample sheet. If needing to generate a V2 sample sheet, this can be done one of two ways. It can be generated using Cloud Run Setup and then downloaded. Once completing the setup, I have the option to export the sample sheet highlighted below. Or we can download the template from the support site and edit using instructions found within the system guide. I have linked to the system guide as well as our V2 sample sheet download. We have our reagents thawing and our run set up. Now let's prepare our libraries. We'll dilute our libraries down to 2 nanomolar. And then we'll follow the system guide recommendations for different library prep types to dilute down to our final loading concentration. And ensure that we use the RSB plus tween that's provided. If using a library prep type that's not included on this list, it's recommended to start with 650 picomolar and optimize from there. Our libraries are diluted. Now let's load them into the cartridge. We'll remove our flow cell from 4C and bring it to room temperature for 15 minutes. And if our cartridge was stored at 4C, this is a great time to bring it to room temperature for 15 minutes as well. We'll want to remove the cartridge from the foil and invert it 10 times to mix. I will note that it's important not to tap the cartridge on the bench after inverting. We'll then remove the flow cell from the foil and insert it into the cartridge. It's also important to note here that we do not need to clean the flow cell. We will then load 20 microliters of double-stranded DNA. And I will also note that the denaturation occurs on board by default on the NextSeq 2000. My next slide is going to be a video that goes through run setup on the instrument. This video was made using a simulator that we have available to us in tech support, so it may look a little bit different than what you guys have on your screens. The simulator will go through Run Setup using Cloud Mode. You will choose Start on the Start menu, log in to your BaseSpace account, choose the appropriate workgroup if applicable, find your run from the run list, choose to review, confirm your run parameters, and then we can choose to load the cartridge. A short video will then play depicting preparing the cartridge for sequencing. Once this video has completed, you can choose to load your cartridge. At this time, the visor will lower and the door will open to load the cartridge. Once the cartridge is loaded, it'll take a couple moments for the cartridge to go into the instrument and for the RFID to be read. Once the RFID is read, you can then proceed to pre-run checks. Once the pre-run checks have completed, the run should start automatically. Reviewing some of the different instrument statuses for the light bar. When loading, the lights will be white and purple. During pre-run, they will be purple, and during sequencing, it will be pink. Once the run has completed, it will be white and pink, and if there's an error, it will be red. Okay, now let's discuss some considerations for different custom libraries. If choosing to sequence low diversity libraries on the NextSeq 2000, it will require a Phi-X spike-in. We recommend between 10 and 50% Phi-X, and it will require a titration to find the optimal spike-in amount. We're also going to discuss manual denaturation, custom primers workflow, and dark cycle custom recipes. Manual denaturation allows us to use libraries that have concentrations that do not meet the recommendations in order to load. Manual denaturation is great because it allows us to load libraries that either have too low of a volume or too low of a concentration to follow the recommendations in our system guide. We have a supplementary document that goes through this protocol, and that document is called the NextSeq 2000 Denature and Dilute Libraries Guide. The protocol is the same for both P2 and P3 reagent kits, and I've linked to this document on our support page here. If choosing to do a manual denaturation, from the settings menu, you will want to deselect the denature and dilute on board. By default, denature and dilute on board is selected. Once we choose to deselect the denature and dilute on board to do manual denaturation, this will become the default setting. So please ensure that if you are running either manual or onboard denaturation, you confirm this setting. Next, for custom primers workflow, I have the guide linked here. Custom primers are spiked in to the custom primer wells as depicted in the image here. If Illumina primers are needed for Phi-X or mixture of custom and Illumina libraries, it does require the purchase of the NextSeq 2000 primer kits. I have the different kit types listed with the part numbers here. Any combination of custom primers is supported and can be spiked in to either well 1 or well 2. A suggested workflow is to combine read 1 and read 2 primers and add them to well 1, and then combine the custom I5, I7, and I5 primers and add them to well 2. 600 microliters of the custom primers are added to the cartridge. Reed primers are to be diluted to 0.3 micromolar, and index primers are to be diluted to 0.6 micromolar. During the Run Setup screen on the instrument is where you will choose to use custom primers. There will be a drop-down box to choose custom primers underneath each reed. With this drop-down box, you can then choose which well the primers were spiked into. Now, we'll talk a little bit about dark cycle custom recipes. There is a section within the NextSeq 2000 System Guide V2 and above that is titled Resources and References, Dark Cycle Sequencing. This includes instructions to edit the recipe file, and it also includes instructions for selecting the new custom recipe when sequencing. We do have a couple of different custom recipes available on our product file page that I have linked here. On the Run Review screen is where the custom recipe can be chosen. I have highlighted the custom recipe section in which you will choose the recipe and navigate to it. Okay, let's talk a little bit about maintenance of the NextSeq 2000 now. We will need to replace the air filter on the instrument every 6 months. This is done by pressing the panel on the top right of the instrument to open the filter door. The filter can then be popped out to remove. The instrument is shipped with 2 air filters. One is installed by your engineer with instrument install, and the other is for you to install at 6 months. If the instrument is under an active service contract, you can contact Illumina Technical Support for additional air filters. If the instrument is off contract, filters can be purchased through Illumina, and I've included the catalog number here. As the instrument runs on the Linux operating software, it should not require regular power cycles as part of maintenance, like many of our other instruments do. But if we do need to power cycle the instrument, this is how we do it. In the control software, we want to open the hamburger menu on the top left-hand side and choose to shut down the instrument. Once off, we'll toggle the switch on the back right-hand side into the off position. We'll then ensure that the instrument is off for a full 30 seconds. For this, I like to set a lab timer to ensure that I am waiting that 30 seconds because it's critical that we do wait the full 30 seconds. We'll then toggle the instrument back into the on position and wait a moment. Once we see the button on the front bottom right side pulse, we can then press it to turn the instrument fully on. After the power cycle, it's expected to take about 5 minutes to boot into the operating system to log in, and then an additional 5 minutes for the instrument to initialize. There are a couple different management options on the instrument. Process management shows us the status of the run as well as the status of secondary analysis. The disk management is supposed to be used to delete completed sequencing runs from the local drive. For best practices, we want to ensure that we have 200 gigabytes of space on the instrument to start a sequencing run. An error will occur at the start of the run if there is not enough disk space. We also want to ensure that we set an output location to a network drive. If a network is not available, the instrument has USB 3 ports for external hard drive use. As I discussed when talking about the reagents, there really is no fluidics maintenance on the instrument. No washes are required. The the Fluidics is housed within the cartridge. A new Fluidics system is used with each new cartridge, and then it's disposed of with each used cartridge. Okay, now we get to take a look at some of the sequencing data. Here, we'll be looking at some of the public data sets on BaseSpace Sequencing Hub. These can be viewed by choosing Demo Data and then searching for the NextSeq 2000 in the search bar. The example we're going to be looking at today is the NextSeq 2000 Illumina Exome Nextera Flex for enrichment. This is what the summary page is going to look like, highlighting some of the key metrics and information about the sequencing run. Then, on the Charts tab, I wanted to highlight the intensity plot. You will notice that about 25 cycles into each read, there is a bump in the intensity. This is caused by increasing the laser power at this point. It is normal and expected to see in the sequencing run. Next, I'll highlight that in the data by lane, percent occupied metric is available for viewing. However, it's really important to note that we should not be using percent occupied to assess the loading of our sequencing runs on the NextSeq 2000. This metric is not optimized for use with a patterned flow cell on the NextSeq 2000 system. Instead, we can use the percent loading concentration, which is available on the Metrics tab on the top side. Next, I just wanted to highlight an example of the Q30 and the error rate, and then some of the key metrics that we can find on the Metrics tab. Since the NextSeq 2000 runs on Linux, and many of us might not be used to the Linux operating software, I've also included a handful of tips and tricks for navigating the system. To check if the control software is open, this can be done similar to in Windows, and we can see if the NextSeq control software is on the bottom gray bar that is visible. If it is not, this can be launched by going to Application on the top left-hand side, choosing Illumina, and choosing the NextSeq control software. To find a web browser, this can be done by choosing Application, Internet, and then Chromium web browser. For file navigation, there may be a file icon on your desktop. If not, this can be found by choosing Application, Favorites, and then Files, and that will open the file navigation window. You may be asked by Illumina Tech Support to navigate to the Illumina folder to find pertinent data or your sequencing run information. This folder might be bookmarked on the left-hand side of your file navigation window. If it is not, this can be found by choosing Other Locations, Computer, USR, Local, Illumina, and this is where that folder lives. I have highlighted several of the folders within there that maybe have pertinent information for you to look at. Now, if we want to bookmark a location, this can be done by navigating to that location, choosing the hamburger menu, and then choosing the bookmark icon. This will then include that location on the left-hand side of your file navigation system. If you're asked to collect data and send back to tech support, this can be done by compressing the folder. Right-click the folder and choose Compress. Once the pop-up window comes up, you can choose Create. Sequencing Analysis Viewer is not compatible with the Linux operating software. Unfortunately, we are unable to use SAV on the instrument itself. Reviewing run data will require an accessory computer to view it. Files that are needed in order to review a run in SAV on another computer are run info, run parameters, and the interrupt folder. BaseSpace Sequencing Hub run monitoring is also a great alternative to SAV to review the run quality. Mounting a network drive on the NextSeq 2000 is quite different than it is for any of our other systems. We have instructions found within our system guide, which are linked here. They can be found under Specify a Network Drive Output, which is found on page 13 to 16 in version 3 of the system guide. This will require IT personnel to help map the network drive. Now that we've gone over the wealth of information, I'm going to talk a little bit about our resources. Here I have linked to all of the pertinent bulletins we have available for the NextSeq 2000, including all of the tips and tricks that I went over in today's presentation. They're available in the top bulletin linked here. I also have links for the system page for the NextSeq 2000, the support page, the system guide, the site prep guide, the V2 sample sheet template download, information about Illumina Proactive, as well as a video on our pattern flowcell technology. This video does specifically talk about the NextSeq specifically talks about the HiSeq 4000, but the technology is applicable to the NextSeq 2000. Thank you so much for taking the time to join me today. I hope this session has been helpful for you.